All right, in this video, we are going to find the area under the curve using the idea of these rectangles, or more commonly referred to as a Riemann sum. This is just kind of a warm-up to Riemann sums. We're going to continue to explore these and get into more detail. So if you were watching another video, you might see more summation notation, but for now, we're just going to talk about finding the area of the rectangles. So what makes this method really nice is that these rectangles are formed by going to a point on the graph. So if you need to know the height of the rectangles, it comes from the value of the function at that point. So let's start here. You see we're finding the area under the curve, function f from 1 less than or equal to x less than or equal to 4. And this function here is f of x equals 5 times 2x, 2 to the x power. So if we look at this first rectangle right here, we can see that this rectangle has a width of 1 and a height of whatever we get out of our function when we plug in 2. So I'll just make myself another line down here. 5 times 2 to the second power gives me 20. So that means that the height of this rectangle is 20. So I have a rectangle that is 20 by 1, and the area of that rectangle is 20. To get this second one, I still have a width of, here's my second rectangle, a width of 1. The height of this rectangle comes from whatever I get out of the function when I plug in 3. You see this point right here is at 3. Changes 2 to a 3. The height of this rectangle is 40. This is a rectangle that is 1 by 40. So I have an area of 40. And then finally, to get to the last one, same idea, I would plug in 4. When I plug in 4, I get 80. So this is a 1. This rectangle 3 is a 1 by 80. If I get that, the area is 80. To get the total area now under the curve here, I would add up 80, 40, and 20. As we can see, this is definitely an overestimate. We're going to continue to work on how to make our answers more precise. So now let's look at what would happen, how we can make maybe this a little more, go step by step or make it a little more helpful. So let's say that instead of 3 rectangles, we actually increased it to 6 rectangles. All right, so I have 6 rectangles. We can see now that each of these rectangles has a width of 0.5. So that's slightly more complicated than when the width was 1, but our life is still pretty easy. We're just going to plug in. A much faster way on a table or graphing calculator to plug into a function is to, or on a calculator, graphing calculator, is to make a table. I'm just going to make a table right here. I'm going to change this to just say x, and this to say f of x. And I don't need to graph this table. So if we look here, my first rectangle actually does not come from this point. We can see that the height of this rectangle is right here. It comes from plugging in a value of 1.5. So if I plug in 1.5 to my function, the height right there is 14.14. So this just does it for me. The next thing I want to plug in to get my second rectangle comes from this point right here, comes from plugging in 2. So I'll go back to my table and I will plug in 2. After that, I want to plug in 2.5. And actually, as you can see, Desmos is noticing the pattern and already guessing what I want to do. So I plug in, I hit enter, 3.5. Quickly, before we keep going, we'll see that we want to stop at 4. That's going to be the height of this last rectangle. Okay, so now I have the heights of all my rectangles. So I have the height of this rectangle, I have the height of this rectangle, and they come from these numbers right here because the value of the function is the height of the rectangle. So I have 1, 2, 3, 4, 5, 6 rectangles. 1, 2, 3, 4, 5, 6 values. Now, to find the area of the rectangle, I need to multiply each of these by 0.5, base times height, and then I will get the area of each rectangle, and then I need to add them all up. So I can do that. Let me switch to a pencil. Down here, and I can take, I'm going to just estimate at this point 14.14 times 0.5 plus 20 times 0.5, 20 times 0.5 plus 28.28 times 0.5 plus 40 times 0.5 plus 56 0.57 times 0.5 plus 80 times 0.5. And as you can see, I've still gotten an estimate. We know that this area is a little bit too high, but I've gotten a lot closer than I've gotten before, finding the area with 119.495. I could continue this process. I could make this have more and more rectangles. When I make this have more rectangles, I need to just look at what the width is. So what I'm going up by right here, from here to here, 0.5. And that's how I know how to increase on my table. One last thing I'll say before we finish up, is that since you are multiplying each of these by 0.5, if I extend this out, as you can see right here, each number is being multiplied by 0.5. You also could use the distributive property, and you could add all of the numbers together first, and that might help your process go a little bit faster. And then you could multiply that whole answer by 0.5. So again, if you think about the distributive property, if you distributed 0.5 to each term, you would get the expression above. So adding them all up and then using the distributive property could help you go a lot faster. So again, we will continue to work on making this more and more precise by adding in more and more rectangles, making the width of those rectangles get smaller and smaller. We'll also continue to explore some ways to make the process more efficient